Welcome back to The Explainer. So today we're diving straight into a massive, monumental global challenge that literally affects every single living thing on Earth. We're talking about river pollution. We absolutely rely on our rivers, right? For drinking water, for agriculture, for industry. But for centuries, they've basically been treated as our personal dumping grounds. So today, we're going to evaluate exactly how we fix this. We'll be looking closely at the different strategies used to manage river pollution all over the world, from pouring heavy concrete infrastructure to much more sustainable green alternatives. It's a pretty staggering question when you really think about it. The sheer scale of river pollution across the globe is just overwhelming, and the effort it takes to combat it, honestly, it's nothing short of heroic. We're talking about trying to reverse literally decades of industrial runoff, agricultural chemicals, and raw human waste. Okay, let's dive into this and check out the exact strategies people are deploying right now to save our waterways. So here's our roadmap for this explainer. We're breaking this evaluation down into 4 parts. First, the heavy lifters, meaning massive infrastructure. Second, working with nature using soft engineering. Third, the rural contributor, which addresses agriculture. And finally, a reality check on the challenges that are still out there. All right, let's kick things off with part 1, the heavy lifters. We're talking hard infrastructure and strict regulations here. When really massive cities face overwhelming amounts of wastewater, they usually have to rely on brute force. Basically, they build, they pipe, and they regulate to stop the pollution right at the source. Think about cities that are going through explosive, rapid economic growth. A prime example of this is Shanghai. As the city just kept expanding, the local government quickly realized they couldn't just rely on natural water cycles to handle that immense volume of human and industrial waste. They've required a drastic, highly engineered expansion of their whole sewage system, literally just to keep their heads above water. And what's really interesting about this slide is how fast they scaled all this up. Look at that jump. In the year 2000, Shanghai had roughly 4,000 kilometers of sewerage pipes. But by 2015, which is only 15 years later, that network absolutely exploded to over 20,000 kilometers. That is a massively coordinated, huge investment in hard engineering. But hey, that sheer brute force actually paid off tremendously. By tackling that massive expansion, Shanghai managed to increase the proportion of treated urban sewage from less than 50% all the way up to about 90% in that exact same time frame. I mean, that is a total game changer when it comes to reducing the raw waste that's entering their river systems. And Shanghai definitely isn't alone in this. Let's jump over to Seoul as another success story. Today, Seoul has this incredible capacity to treat 3 million tons of sewage every single day. Before they made these upgrades, a terrifying 87% of the city's sewage was flowing completely untreated right into the Hangang River. And it's not just about building bigger pipes, it's also about laying down strict rules. Over in the Pearl River Delta, authorities rely really heavily on regulations and finding polluters right at the source. They're slapping higher sewage treatment charges and much stricter pollution limits on factories to basically force them to comply. So the crucial point we need to take away here is that while heavy infrastructure is incredibly effective in mature economies, it carries a massive, sometimes totally prohibitive price tag. Because of that crazy expense, in rapidly industrializing areas like Guangdong, half of the wastewater is unfortunately still just dumped right into the rivers untreated. And that huge cost barrier naturally begs the question, isn't there a more sustainable way? Which perfectly pivots us to methods that actually rely on natural processes. That brings us to part 2, working with nature through sustainable soft engineering. Instead of trying to fight water with concrete, sustainable management is all about working alongside natural processes to filter out pollutants and actually restore the whole ecosystem. A major technique here is something called dechannelization. For decades, engineers used to just straighten rivers into these rigid concrete channels to control flooding. Dechannelization does the exact opposite. It reestablishes a river's winding, natural flow and brings back its floodplains and wetlands. Why? Well, because restoring those wetlands serves a super important nutrient filtration function. By naturally filtering the water, it decreases the harmful nutrient loads that would otherwise rush into downstream bodies of water, like Lake Okeechobee over in the United States. But hold on a second. Before we just assume that doing things the natural way automatically means it's cheap, consider this staggering number. $980 million. That's the estimated cost of the Kissimmee River Restoration Project in the US, which is this massive dechannelization effort. So yeah, soft engineering can still be extraordinarily costly. And honestly, the irony here is just profound. Get this, the original cost to channelize the Kissimmee River, like to dig the straight ditch that ruined the ecosystem in the first place, was only $20 million. When you evaluate this, it becomes so clear that trying to reverse ecological damage and artificially recreate these natural systems is vastly more expensive than the brute force engineering that destroyed it to begin with. Yet, even with those steep costs, the results can completely transform a society. Just look at another restoration example, the Changye-Chen River back in Seoul. This project was absolutely central to the city's urban regeneration. They took this waterway that was horribly polluted with highly dangerous heavy metals like lead, chromium, and manganese, and they managed to restore it into a vibrant, clean public space right in the middle of a bustling metropolis. And this brilliantly illustrates how forward-thinking cities can plan for the future. Take Curitiba down in Brazil, for example. Their whole model of natural urban planning dictates that the environment is used, not fundamentally changed. Instead of fighting the landscape, they preserve natural drainage pathways and actively use floodplains as public parks. So when the river inevitably swells from heavy rain, the parks just flood naturally. It manages the water quality and the runoff perfectly without causing billions of dollars in property damage. Brilliant, right? Moving right along upstream to part 3, the rural contributor. Let's talk about managing agricultural pollution. Because dense urban centers aren't the only problem here. Way out in the countryside, agricultural fertilizers and pesticides are massive drivers of river degradation worldwide. If we don't manage agricultural pollution, all our fancy city infrastructure downstream is just fighting a losing battle. So here are 3 really vital, sustainable strategies being used to fix farm runoff. First up, organic farming. By totally avoiding manufactured chemicals, you ensure there is absolutely zero nitrate runoff into the streams. Second, soil conservation. Using physical techniques like terracing stops the rapid runoff of irrigated water, keeping all that dirt and sediment out of the river systems. And third, waste reuse. Sustainable eco-cities, like Dongtan, are actually processing their sewage for irrigation and composting, totally avoiding discharging it into major rivers like the Yangtze. Similarly, Shanghai is actually taking municipal organic waste and using it as fertilizer in its surrounding rural areas. It's an incredibly efficient closed-loop system. Finally, we arrive at part 4, the reality check. Let's look at the ongoing global challenges we're still facing. We've explored some truly innovative strategies today, but gotta be real with you, despite these great advancements, severe, systemic challenges absolutely still remain. You definitely need to know this high-level term, the brown agenda. It describes a really dangerous phenomenon. Basically, in cities experiencing massive, rapid economic growth, environmental problems tend to concentrate so fast that they completely outpace the local government's ability to monitor and manage them. When factories are just popping up overnight, local authorities often lack the resources or even the manpower to safely monitor toxic, hazardous waste before it hits the watershed. Furthermore, even if you have perfect regulations on the books, incidental pollution from industrial accidents can still wipe out decades of progress in a single afternoon. Consider this shocking reality, 108. Back in 2005, the Harbin petrochemical explosion released highly carcinogenic benzene right into a major river. The contamination levels hit 108 times the acceptable safety limit. Managing pollution is just incredibly complicated when one unpredictable accident can cause that magnitude of devastation. And finally, we have to recognize a simple truth. Water does not respect lines drawn on a map. Cross-border issues make river management phenomenally difficult. When a river is international, pollution from a factory in one country simply drifts right downstream into another. We see this constant friction with things like acid rain and industrial discharge flowing freely across international borders in regions all throughout Europe and Asia. You can have the absolute best local infrastructure in the world, but if your neighbor upstream doesn't, your river is still dying. Which brings us to our final slide, and really, the ultimate question for this explainer. Can local solutions ever truly solve international pollution? We've seen today that hard infrastructure, natural dechannelization, and smart farming all work absolute wonders on a local level. But when we look at a fully connected global ecosystem, it forces us to evaluate the limits of those individual, isolated strategies. It's a complex, giant puzzle, and honestly, it's one we absolutely have to solve. Thanks for joining me on this explainer. I'll catch you next time.